It's often said that architecture can decide the application speed way more than any given language or framework. But what does it mean exactly? Well, in this video, I will try to explore one such architecture that can allow instant interactions for users and really fast speed. So I'll just start with a demo of like a real example of this. So we have an example application of a project management app. You have tasks, you have organizations, you have priorities of the tasks and labels. So let's make an interaction. For example, let's remove these labels. You can see that the interaction is instant. And if I open a new window and I sign in, I will go to the same tasks section, task view, and I will open those windows side by side. And let's try to remove some labels. And you can see the interactions are instant. And the reason is because of the local first architecture we're using here. So let's take a look at like high level illustration of how this works and how it compares to a classical architecture. In a classical architecture, you usually have a server part and a client part. And the server part could be built by PHP or C# with .NET, TypeScript. It doesn't really matter, Ruby. It usually has a database, and it has some kind of way to communicate to the client of the current state of the database. So usually through REST API, maybe GraphQL sometimes. There are some modern solutions like TRPC, which are really popular in the TypeScript world. React server components as well, quite hype right now. And in PHP world, there is Livewire for Laravel. None of these technologies will allow to make such performance I just showed, because all of them need to cross the network boundaries. So if your server is in the US and your like application server or front end is in Europe and your user is in Australia, for example, then you'll have latency and slow network responses regardless of how much you optimize the server. So this is where the local first architecture comes in. As you can see, it still has the server and the client parts, but the client is a lot beefier. It has its own data replica. Usually it's local storage or embedded SQLite or something like that, or IndexedDB. Like in the example I just showed, it's actually using IndexedDB. I will give more information about it later on in this presentation. But IndexedDB is quite good for small data sets. It's good enough for this application. So what happens is when I interact as a user, all the interactions are instant because first they are written into the client replica. And the sync engine, in my case, it's Replicache Successor 0, which is doing this work. It replicates it to the database in the background. So as a user, I can get instant interactions on all my clicks. And if I have multiple users in the same application, they might feel like it's like a real-time collaborative app because you don't have to wait for the network for each click. So that's the high level of it. And usually those sync engines have some kind of WebSocket connection as well to stream the updates from other clients. So that's important as well because you don't even need a sync engine to have local first experience in the sense that you can write the data to IndexedDB with just vanilla JavaScript. But it's crucial to have WebSocket connection if you want your application to feel real time. That's the theory. Let's have a look at the code examples. So this is the same application, open in Cursor. Let's start with the database schema. So you have some basic database tables, some session tables, account tables, organization, member. Let's go down to the task table? Yeah, so we have task table defined in TypeScript, in Drizzle, and it will generate the SQL definitions to create this database. But if you look at our architecture, we're really looking at the server side right now. So this is the database on the left, but for those instant client interactions, we also need to define the replica, the client replica schema as well. So I have a sync engine schema here, which is a subset of the main database. So it doesn't require to have all the tables, all the columns inside the tables. I only need to sync the tables that I care about. For example, in this multi-tenant app, I don't necessarily want to maybe sync the organization data in my sync engine or teams. I only care about things that will change often, like tasks or labels or priority of the task. So I'm only syncing those tables to the client. And you can see that like I actually have fewer tables with fewer fields compared to the database. And this is just permission stuff related to implementation details of Zero. But different sync engines will have this solved differently. So we don't need to focus on that necessarily. But the main concept still remains that you only sync the data you need. Now, if you have used a tool like React Query, you will be very familiar with something like this. Just a simple React hook that fetches data in the background. I'm filtering by organization and by slug for this task to fetch the task, and I'm putting this data into use task hook. So my UI doesn't need to know where the data is coming from, but it shows that like implementation side, it's not that much harder to implement this than a regular React query or gRPC. Yet for the user, the application feels much faster and much higher quality in terms of interaction speed. So this is the curious, but of course we need to mutate the data as I showed earlier. So if you look at mutators, for Zero specifically, we have custom mutators concept. And here we're pressing the transaction from the user. So insert the task, update the task, and we're updating the local store first. And then the sync engine in the background updates the source of truth, which is the database on the server. So when you connect all those things, if you look at the demo again, you can have those instant interactions, and they are also synced. So for example, if I was to log in with a different user into the same team space or workspace, I would get the interactions. So let's have a look at like when this architecture is good and when it's not so good, because it has its downsides, of course. So some of the good use cases are B2B SaaS apps, like email marketing tools, email clients even, because you have a lot of things coming in from other users, and you want to see them instantly, and you want to see your changes instantly as well. But consumer apps as well, like if you have like a mobile app that needs to feel instant and it's like editing videos or adding captions, it might be a good use case. Internal dashboards, it might be quite complex to implement for internal dashboards, but it would be a nice improvement. But of course, there are suboptimal use cases as well. If you look at marketplaces or e-commerce sites, social networks, usually such applications have a lot of data that's not yours. They're not specific to your tenant. So you might scroll through the feed in Twitter, for example, or X, and you might see content from other users, and you might not want to sync all of that into your browser, basically. So this is where you might want to sync certain subsets of data, but for sure not entire application. So yes, it's good to keep in mind, because it's not like a silver bullet for all types of applications. But if you compare the classic architecture I showed earlier on, this is the opposite, because if you're building a SaaS application, a B2B SaaS application, where you have the multi-tenant setup and you're usually viewing your own organization data, then not having such architecture becomes an issue because it will feel slow and sluggish. And if you use tools like Jira, for example, you've seen that usually they take a lot of time to load, precisely of this problem of having to sync each interaction with the server. And it doesn't matter like how fancy you get. As I mentioned before, you might have GraphQL, you might have gRPC, React Server components. All of them have to go through the network to display user interactions. Of course, I should say that this is also has to go through network, obviously, but it doesn't have to at the point of interaction. That's why it feels so fast. And if you look at more modern applications like Figma or like Linear, especially Linear is a very famous example of this, they usually have this type of local first system, and that's why those applications feel a lot faster. So yeah, hopefully it was useful. Personally, I'm really passionate about this stuff. I feel like it's definitely under explored and underused. For example, if you compare the hype that React Server components received compared to local first, I would say React Server components are way more like advertised, and in the reality, like they don't necessarily contribute to better applications in all of the cases. It might be nice for e-commerce sites or marketplaces, but definitely not for like B2B SaaS apps, for example. And lastly, let's take a look at some libraries that I would recommend. For example, in this example, I've used Zero. It's one of the leading solutions, I would say, because the team that created it created Replicache as well, which was also quite well-known system for local first. The upsides of this, for me, it was very similar to React Query in terms of its API, which I love, because I love this type of simplicity I showed in the hook. Like if you come back to the code, yeah, it's very simple to read. The downsides, it's quite complex to set up. If you look at my infrastructure definition, I've used AWS, and it was a lot of services. I think it has virtual private cloud for managing containers. Of course, that's AWS specific thing, but still you need to set that up. The replication database, the main database, the replication manager service, the view syncer service, and of course your actual front end. So, it might add up in terms of hosting, but in all fairness, they do have other guides as well. Like you might use other solutions, not necessarily AWS, to host this. So it might be cheaper and simpler. But for me, on AWS, it was quite complex to set up and maintain. And the other solution I would recommend is LiveStore. It's made by the creator of Prisma, the original creator of Prisma, so you might know Prisma, the ORM of TypeScript. This one feels a lot more like Redux, if you remember Redux in terms of its design, which personally I'm not as fan of, because I can't really figure out like how to use those slices of state and how everything connects together, where to put the business logic. It just feels weird to me, but they have a different approach as well. They're more event driven, and I think like if you dive deep, like it makes a lot of sense, and it's just a different approach. You can see the demos of instant interactions. You can see like a music player app, which is a good example of local first. So hope this was helpful.